Okay, here's a question from a student. I have a problem with question 130 on complex numbers and their operations. Let's see. Show that -2, 1 minus I, and 1 plus I are solutions to the equation. Now here's the equation right here. X cubed minus 2x plus 4 is equal to 0. Now, this is called a quadratic equation, and as you know, there are no factors of 4 that will combine and give you the -2. Also, keep in mind that this is not a quadratic, this is a cubic, okay? So really, I could write it as x cubed plus 0x squared minus 2x plus 4 is equal to 0. Now, what we're going to have to do is we're going to have to try to see if we could break this down. There should be 3 factors here, okay? 3 factors. Well, we're going to use the rational roots theorem, which says any factors of 4 over 1 could be a possible root to the problem. So let's see if I could say that another way. Well, first of all, it said, show that these 3 are the possible answers to the equation. They're all solutions. If that's true, then x plus 2 is a solution. X minus I minus 1 minus I is a solution. And x minus 1 plus I is a solution. Okay? I mean, that's just, let me just hit that again. If 3 was a solution and -2 is a solution, then x minus 3 would be a factor, and x plus 2 is a factor. Okay? I may have got a little ahead of myself, so let me just erase this here, okay? Now, what we're going to have to do is we're going to have to actually multiply all these factors out, okay? Let's rewrite them. X plus 2, we understand that. This is x minus 1 plus I. And this other factor is x minus 1 minus I. Now, we're going to have to multiply all 3 of these together. And if we multiply all 3 of these together, I should get that polynomial. All right, the first thing I'm going to do is I'm going to use what's called box method, okay? And, well, I'm going to need another row here, okay? Okay, so the first one was x minus 1 plus I, and the other was x minus 1 minus I. All right, let's multiply row and column, row and column. That would be x squared. I'm trying to find a brighter color here. X squared, this would be minus I squared. This would be negative x. This would be positive ix. This would be a negative x. This would be a plus 1. This would be a minus I. This would be minus ix. This would be plus I. Okay. Now, do any of these divide out or additive inverses? Yes, this one and this one. Then I have minus ix and plus ix. Now remember, negative I squared. I squared is -1, so negative 1 is just positive 1. This is just positive 1. Now let's put all of this together. So far, when I multiply those two, I have x squared minus 2x plus 2. Now, what's going to happen if I multiply this by x plus 2? X plus 2. Okay, well, I could use box method that I used here. I'll show you another method of doing this. It's very simple. So we're going to multiply everybody by this plus 2. The top by the plus 2. That's going to be 2x squared minus 4x plus 4. Now we got to multiply everybody by the x. That's x cubed minus 2x squared plus 2x minus 2x squared plus 2x, and that's it. Now let's add all of these guys together. X cubed, this goes away, minus 2x plus 4. Now, does this match this? Okay. Question. Show that this, and this are all solutions to this equation. And I just showed you if we multiply them all together, it works. We can actually substitute the values in there. We could substitute in there -2. So -2 cubed minus 2 times -2 plus 4 is equal to 0. That's -8. Plus 4 is equal to 0. -8, that's just 0. 0 is equal to 0. Okay, so that is a solution. There were 3 ways of working that problem. I hope that explained it to you. I wish you well.